Okay, let's talk about the rational zero theorem. The first thing you need to keep in mind, so we're going to have a little note section, is the following. P over Q. So what does P over Q state? Well, P refers to the factors, right? So let's write that down. The factors of my constant. It's the factors of my constant. And Q is the factors of my leading coefficient. So what exactly is a leading coefficient? Well, a leading coefficient is a number that's placed in front of x which has the highest degree or the highest power. So in this case, it's 1. Well, what is a constant? Well, a constant is just a number without a variable in my function. So in this case, we have 6. So let's go determine the factors of 6. Meaning, what can 6 divide into? Well, it can divide into both plus minus 1, plus minus 2, plus minus 3, and then plus minus 6. So the idea is to find the f of x where, so let's write down what's the idea. So the idea is to find the f of x at some x value which is equal to 0. Now I have to first place this all over 1 because remember it's p over q. So the factors of my leading coefficient is simply 1. So let's test this now. Let's find, you don't have to write this, I'm just doing this for the video. Let's find the f of x where it's equal to 0 at some value. Okay. Well, I'm going to start by testing x is 1. So let's see. So 1 raised to the third power is simply 1. Maybe I can write this out quick. Okay, I'm going to write this up, but I'll speed the time. Okay, let's solve. So this gives me 1 plus 2 minus 5 minus 6. That gives me negative 11, 10, negative 8. Okay, therefore, we can conclude, well, negative 8 is definitely not equal to 0. Let's test a new one. Let's test 2 this time. Sometimes these testing might take forever, by the way. You have to test like maybe 12 numbers or something. Anyway, let's see. So it's going to be 2 raised to the third. 8 plus, what's that? 8. 4 times 2 is 8. Minus 10. Minus 16. That gives me 16 minus 16. Which is then equal to 0. Okay. Now what's the point when we find f of x is equal to 0? Well, after using the rational zero theorem, where we found the 0, we can now say, well, the first x of my equation, because remember, all we're trying to do here is we're trying to find my 3x values, right, with this theorem. So my first x value is then 3. Now, 2, excuse me. Well, now that we have this 2, we can move over to a new concept, which is called synthetic division. You can also do long division, but I'm going to do synthetic division. So let me rewrite this function. This function was the f of x is equal to x cubed plus 2x squared. Is that correct? Yes. Minus 5 x minus 6. Now the idea is that I'm going to place my 2, let me increase this. I'm going to place my 2 over here. And then my coefficients, I'm going to input into this box in the correct order from highest degree to the lowest degree. So now what we want to do is we want to follow a simple method. It's almost like a zigzag puzzle. So the first thing you want to do is you want to bring this 2 down. When you bring the 2 down, or the 1 down, excuse me, becomes 1. What we then do is we're going to take this 2, we're going to multiply it by the 1 and write the new value in this spot. So the first number you always bring down. So 2 multiplied 1 is 2. Then we're going to add downwards. Okay, we add downwards. So 2 plus 2 is 4. Now I'm going to repeat the process. The process is 2 multiply 4 gives me 8. And I'm going to move downwards, add downwards again. That gives me 3. Then I have 2 multiply 3, which is 6. And negative 6 plus 6 is 0. Now I all of a sudden found my new coefficients for my quadratic equation. So we just divided this function with x minus 2. Okay, well, you see positive 2 over there, but we just solved for 2. Okay, we moved it from the left to the right. So now we solved it. And now we can use simple factoring of a quadratic equation to solve this. So if I do that, I can say, well, x plus 3, x plus 1. And that's then going to give me 2 separate values. Well, the 2 values will then be x is equal to negative 3 and x is equal to negative 1. So I just found my 3x values. So my 3x values is x is equal to negative 3, x is equal to negative 1, and then x is equal to 2. So I can rewrite this as three brackets to say, well, x plus 3, x plus 1, and then x minus 2 is in fact equal to x cubed plus 2x squared minus 5x minus 6. So this is how we use the rational zero theorem. So just to recap, the idea is to find the factors of p, which will be the factors of my constant, over the factors of my leading coefficient, which is 1. And then we want to try find a 0. After we found 0, we then know, well, one of my x-intercepts is going to be 2. Then I'm going to use the process of synthetic division to simplify, to divide my given function with the x, with one of the x-intercepts. If I do that, I get a quadratic equation. Quadratics are very simple to solve. If the quadratic equation becomes a little bit more complicated, we can always run back to the x sub 1, x sub 2 is equal to negative b plus minus the square root of b squared minus 4ac over 2a, also known as the quadratic equation. Okay, so we just solved all the x-intercepts. Now we'll quickly go over to a Desmos to show what the function would look like. Okay, so if we look at this function, well, we can see there's one of our x-intercepts, the ones we just calculated, negative 3. If we look at the next intercept, we can see, wow, there's negative 1. And then if we look at our final x-intercept, remember an x-intercept is just a point where my function crosses my x-axis. And we have 2 as well. And then when we go back to ours, we can see, well, x is equal to 3, negative 3, negative 1, and 2.